So this next unit is looking at chemical formulas and how to name them. So chemists all around the globe use the same system when coming up with the names and formulas of compounds, and therefore it makes it easy for all of us to communicate with one another. So in order for you to join that community, you too are going to have to learn how to come up with the proper names and formulas for chemical compounds. It'll be important in terms of lab safety as well. So if a bottle says the name and your lab says the formula, you're able to switch back and forth between the two and keep sure you're using the right equipment and chemicals. So all elements have an atomic symbol. That symbol is going to be one capital letter or one capital letter and a lowercase letter that designates which element it stands for. A chemical formula shows you both the name or the types and how many atoms of each element are going to be within the compound. So for example, if I have P2O5, the capital letters tell me that I have two elements, phosphorus and oxygen, and the subscripts to the right tell me that I have a ratio of 2 to 5. I've got 2 phosphoruses and 5 oxygens within that molecule. So there are two main naming classifications, the stock system and the Greek prefix system. We're going to start with the stock system. So it's appropriate to use the stock system when naming ionic compounds. And you'll recall that an ionic compound is formed between a metal and a non-metal, or also if we have a polyatomic ion within the compound, we'll also be using the stock system. And the stock system is all about oxidation numbers or charge. So you'll notice as we go through this, it's all about getting the charges correct. We also need to be able to go from the name to the formula. So given the name, can you come up with a formula? And the key to this is that ionic compounds are neutral. So the total charge of the cations and the total charge of the anions must be equal. So we're going to go through a series of steps, and you'll see that by doing these steps, that's exactly what we do. We make sure that the compound is neutral. So you can see we're going to look at aluminum sulfide. The first thing you want to do is change the names to symbols. So the symbol for aluminum is Al. Sulfide is the element sulfur with its ending change, so that would be S. And then you want to assign oxidation numbers. In our previous unit, we showed you how to assign them, that the metal would lose all of their valence electrons and have a certain cation charge, and the non-metals would gain as many as they needed to get to a full valence level, and they would have some kind of anion. So you can look right on the periodic table for the representative elements. So if I find aluminum, here it is in group 13, and all the atoms in group 13 have 3 valence electrons and lose them and become +3. So I'm going to put a +3 in the upper right for aluminum. Sulfur is over here. Sulfur has 6 valence electrons. It's going to gain 2 more to get filled, so it'll have -2. And you can see that wouldn't be neutral in terms of charge. I got a +3 to -2. In order to make the charges neutral, we're going to drop them and crisscross. So the subscript or the superscript for one becomes a subscript for the other. So I'm going to get rid of the plus and minus, drop the charges, and then crisscross. And you can see that the superscript for one became the subscript for the other. The last bit is just cleanup. We don't include ones, and you need it to be in the lowest whole number ratio for these formula units. So Al2S 3 would be your final answer. Can't reduce that down. And if you look at it, you can see that I have 2 aluminums as my subscript, and each one has a charge of +3 for a total cation charge of +6. And I've got 3 sulfurs, each with a -2, so 3 times -2 is -6, and they cancel out to 0. We're not going to do this to show you for each one, but recognize that's what happens when you do the crisscross and why it works to make the compounds neutral. So our next example is lithium bromide. Write the symbols. So lithium is Li, bromide is the element bromine. Assign oxidation numbers. Lithium's in group 1, so it's +1. Bromide's over here, it's a halogen, it's -1. And now I'll drop the charges and crisscross. So drop the charges, crisscross, and I've got Li1, Br1. We don't include the 1, so this will just clean up to be LiBr. Calcium nitride. So first thing I want to do is write the symbol for the elements. Calcium is Ca, nitride is the element nitrogen. And assign oxidation numbers. Calcium is a alkaline earth metal, so right there, +2. Nitrogen has 5 valence electrons. It'll gain 3 and become -3. Drop the charges, crisscross, and then clean it up. Ca3N2. Magnesium oxide. So magnesium is Mg, oxide is oxygen. Assign your oxidation numbers. There's my magnesium, so magnesium is +2. Here's my oxygen over here, -2. Drop the charges crisscross, and I get Mg2O2. You should notice that these are not the lowest ratio. A 2-to-2 ratio can reduce down to a 1-to-1, and you must reduce it down to a 1-to-1. So Mg2O2 must be reduced down to Mg1O1, which just becomes MgO. So need to be in the lowest whole number ratio. Barium iodide, write the symbols. Barium is Ba, iodide I. Assign your oxidation numbers. Barium right here, +2. Iodine's a halogen, -1. Drop the charges crisscross. Get rid of that 1, such as BaI2. So why don't you pause and try these 5 out, and then unpause when you're ready to check your answers. 1, 2, 3. So lithium is +1, oxygen is -2, Li2O. Radium is +2, sulfide's -2. Reduce it down from a 2-to-2 to a 1-to-1, so RAS. Magnesium's +2, bromine's -1, crisscross, you get MgBr2. Sodium's +1, fluoride's -1. Don't include the 1, so just NaF. And aluminum's +3, oxygen's -2, crisscross, and you get Al2O3. So that does it for the simplest type of naming, binary stock system with metals with fixed charges. Next time we'll look at metals that have multiple charges.